Okay. Wait, am I sharing the right thing? Yeah, we're good. Okay. So doing sum and difference of two cubes, which at first looks like, that's totally not prepared today. Looks like it might be kind of confusing when you look at the actual formulas themselves, but I promise you it's not that bad. I would write these two formulas down. Sum of two cubes, a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. And the difference of two cubes, a cubed minus b cubed, is a minus b, and then a squared plus ab. So here is the only two differences between those two formulas are just the signs here, right? So this is a plus b, a minus b, and then if it's a plus b, you put minus ab in the middle, plus ab down. Okay. The other thing that would probably be beneficial for you to do would be to write down your list of perfect cubes. Like 1 to the third power is 1. That's not useful, but whatever. It starts off the list. 2 to the third power is 8. 3 to the third power is 27. Let's put it over here so I don't get in the way of my work. 4 to the third power is 64. 5 to the third power is 125, and 6 to the third power is 216. Okay. There you go. So this will help you out. You're going to see these 6 numbers. You can go further if you really wanted to, but I don't think you're going to see anything bigger than 216. Okay, so let's try it out. So what we do is we look at our two terms, and we say, are both of those perfect cubes? Can I take the cube root of 27? Can I take the cube root of x to the third? And can I take the cube root of 8? And the answer is yes. So we saw that 3 cubed is 27. So the cube root of that would be 3. Right? X to the third power, the cube root of that is just x. Right? And then minus 8, we saw over here, the cube root of 8 would have to be 2. Okay? So all I've done is I took the cube root of both my terms, because we saw here we have this difference of cubes. So we started with a cubed minus b cubed, so we just take the cube root of both of those to get a and b by itself. Okay? All right, once we do that, that's the hard part. Then you ignore the original. Don't look at this anymore. All we're looking at is the 3x and the 2. Okay, so then it says our next term up is a squared. So since a was 3x, we're just going to square that. 3 times 3 is 9. X times x is x squared. Our middle term is plus ab. So I'm just going to take my two terms, multiply them together. Don't look at the sign, just the number. So 3x times 2 is 6x. Because our formula says this has to be plus, so I'm not even looking at the minus one. Okay, this is just going to be positive. Then at the end, b squared. So 2 times itself, 2 times 2 is 4. And then that's it. That's our whole solution. I can uncross this off. So all we did is we just factored it out. And this would allow us to solve it, to figure out some of the solutions. Like we could set 3x minus 2 to 0. We could set 9x squared plus 6x plus 4, and then use the quadratic equation to get our other 2 remaining solutions. Okay, but that's all we need to do right now is just factor. Okay, not too bad. Let's try one more. So our second one, we see 81, x to the third, 24, y to the third. So you might see it's like, oh, 81, that sounds like a perfect something or other. So 81 is a perfect square, but it is not a perfect cube, which means this rule wouldn't work, right? Because this is not a perfect cube. But we have to be able to do something with it. So what can I divide 81 by that'll get me back to one of the numbers on my list over here? And hopefully you see, well, what if I divide the whole thing by 3? So if I factor out a 3, 3 times 27 is 81, x to the third. I also need to factor out a 3 from the other side. So 24 divided by 3 is 8. And look at that, 8's on my list too. What a day. Y to the third. Okay. So now I have 27x to the third, 8y to the third, and that's, well, that's what we just did, so that's nice. So we can simplify this, or we can factor it rather. Don't forget about this 3 on the outside, right? So we're going to bring that down 3 times. And then it's the same thing we did before. So the cube root of 27 is 3. Cube root of x to the third is just x. But this time, since it's the sum of 2 cubes, we know we're going to put plus first. So 3x plus, and then we have the cube root of 8 is 2. The cube root of y to the third is y. Okay, it's not exactly the same. I forgot there's a y here. Okay. So same as before, when I fill out the second part, this a squared minus ab plus b squared, I'm not looking at the original expression anymore. I'm only looking at this 3x plus 2y, because that's my a and that's my b. So I want a squared, so 3x times itself is 9x squared. And then I know since it's the sum of 2 cubes, I'm going to subtract next. I'm still going to multiply them together, so 3x times 2y would be 6xy. And then it's always plus b squared at the end, so 2y times 2y is 4y squared. So this whole thing is equivalent to our original expression. Okay, there you go. Sum and difference of 2 cubes lets you factor some pretty specific types of cubic functions. So give them a try. I promise you it's not that hard. Once you do a couple of them, you'll be like, oh, Ellis, this is actually super easy. Why did you make it look so difficult? Sorry. But if you have any questions, let me know. Otherwise, good luck and have fun.